This is A2Pure maths, and we're dealing with trigonometry, and we're introducing our 3 new trig ratios. So the ones we have already are sine, cos and tan, and this is just to introduce then 3 new ones, which are sec, cosec and cot, which are short for secant, cosecant and cotangent. So sec x is defined as 1 over cos, cosec is 1 over sine, and cot then is 1 over tan. I remember whenever I was taught these, my teacher told me that it seems strange, these ones seem the wrong way around. You would have thought cosec would be 1 over cos, and that sec, because it begins with s, then is 1 over sine, but it's actually the other way around. So that helped me to remember that. So that's where we are then from there. So sec x is 1 over cos, cosec x is 1 over sine, and cot x then is 1 over tan. So you might be asked then to evaluate something like that. Sec of 137. Sec of 137 is the same. Then we know sec x is 1 over cos x, so that's the same as 1 over cos 137. You can do this a couple of different ways. Cos is going to be negative in the second quadrant, which is what that is. So it's the same as 1 over minus cos of 43. Cos of 43, you put it into your calculator, you get 0.7314. So it's 1 over that, and then if you put that in your calculator, you get 1.37, the 3 significant figures. Cosec of 231 then is the same. Cosec is the same as 1 over sine, so that's the same as 1 over sine, 231. Again, we're in the third quadrant there, so that's the same as 1 over minus sine 51. That's the same as 1 over minus 0.7771. All I've done is hit sine 51 on my calculator, you get that. And put that in the calculator, you get minus 1.29. Finally, 1 then for cot. Cot is the same as 1 over tan, so cot 253 is 1 over tan 253, which is the same as 1 over tan 73. No minus there, note, because this one's in the third quadrant, so tan of something in the third quadrant is indeed positive, so we don't need that. That's 1 over then 3.2708, and that gives us 0.306. Next wee bit to chat about just very briefly now is another name for our sine to minus 1, cos to minus 1 and tan to minus 1. These are inverse trig functions, the ones where you've been doing them for years now, since year 10, just where you'd hit shift sine. Another name is arc sine, or arc cos, or arc tan. So if you see those in questions or see an exam, it just means second function or sine to the minus 1. Nothing too taxing there. Let's take a look then at a few questions and we'll see how we get on. Example 2 said solve the following equations for x between 0 and pi. I'm going to change that incidentally, but we'll talk about that in a wee second. So our first one is sec x equals minus 1.367. This one I'm actually going to solve between 0 and 360, just to get us used to our solving with these 3 new trig functions. I don't want to confuse people with radians. We'll bring in radians in for the third example probably and see how we get on. So sec x equals minus 1.367. Sec x we know is the same as 1 over cos x, so that ends up being that. We can rearrange that to have cos x equals 1 over minus 1.367, and so we have cos x equals, if you stick that in your calculator, minus 0.7315. I haven't bothered with my basic angle here, excuse my laziness, but you can do it this way anyway. So cos minus 1 of minus 0.7315 just gives me 137. Because it's in the second quadrant there, then it's going to be negative. We're looking for where cos is negative. So I'm going not to 360 here, so it'll be 0, 90, 180, 270, and 360. And CAST, we want cos to be negative. It's going to be negative here, which is my 137, and also here. So if you do the sums for that, then you're going to get 223. I hope you follow that okay, not doing the basic angle. We could of course just do the basic angle, which would be actually was cos of minus 1, 0.7315, and we'll get maybe 43 I think there, but we want cos negative, so we're not going to take that one. We'll take that one and that one, and it would give us then the same answer. Let's take a wee look at our second example. So cosec x is 2.164. I'm going to solve that one as well, I think between 0 and 360. So cosec x is 2.164. That means 1 over sine x is 2.164. So sine x is 1 over 2.164, which is 0.462. That's already positive. That's okay. X is sine to the minus 1 of 0.462. Sorry, I've said that the wrong way, didn't I? You put that in your calculator and you're going to get then 27.5. So doing our diagram out, we have 0, we will have 90, we have 180, we have 270, we have 360. We need to solve between 0 and 360, and we want where sine is positive. Sine's positive there, so we're going to get 27.5, and the other place sine is positive is going to be here. So C, A, S, and T will give us our two values there. So the other value for that is then going to be 180, take away 27.5. I should be ashamed of myself using a calculator for this, but that's okay. And that of course gives me 152.5 degrees, or my two answers then for those. Finally then, let's do cot x, and that then is going to be cot x equals 1.213. Let's solve this one then between 0 and 2 pi. And so we'll need to do some calculations here, but we'll see how we get on. So what do we know? We know that 1 over tan x is 1.213. We then know that tan x is 1 over 1.213, and that gives me 0.824. So my x is then tan to the minus 1 of 0.824. So I first of all need to go back into radians here, and I'm doing tan to the minus 1, 0.824. And that gives me 0.689 radians. So we then will do our cast diagram. Let's do it across here. Remember now we're in radians, so we're going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi, C, A, S, T. What are we looking for here? We are looking for when tan is positive. So it's going to be this one here, which is our 0.689. And the other place tan is positive is going to be here. So we want this one here, and we want this one here. So our values for x then are going to be 0.689. And how am I going to get this angle here? I'm going to have to add pi to the 0.689. So 0.689 is already in my calculator, plus 3.83. And that's us.